And welcome to my short series where we explore certain features of the C++ language in an Arduino environment. Hints, tips, tricks and traps. Now, before we start talking about pointers, smart pointers, references or anything like that, let's think about why there's even a perceived need for this. Yeah, after all, if you're looking at the code on the screen, we've been calling functions without such additions to our code for decades, right? We just write a function, give it some parameters, call it, and everything's great. We don't need anything else, or do we? I want to have a big shout out for PCB Way, PCB Prototype, the easy way. Now, you know I've had many PCBs created by PCB Way, and now they've got a up to 50% off PCB Way Christmas sale. Let's have a look. So this is running from the 1st of December to the 31st of December, and it's up to 50% off. As you can see, there's lots and lots of coupons available, so now's a good chance to get that PCB ordered. And you can get started with just $5. And remember, your first PCB is absolutely free. Look at the front page again. If you're new, this is free for your first order. Look at that. It's certainly worth trying them out. And if you're an experienced PCB designer, you can get things like aluminium PCBs, as it shows you here. Not just that, of course, they do many different types of PCB, flexible ones, custom, bespoke, assembly, you name it, they do it. And not just that, they even do CNC 3D printing. The options here are endless, certainly worth a look, and I highly recommend them. PCB Way, PCB Prototype, the easy way. Let's look at the code on screen then. Now you can see there, first of all, there's a very simple swap function that I've written. Yeah. Now, before we start looking at the code, yes, this is written in Platform.io, or at least it's running on Visual Studio Code. I've got Platform.io installed, but I'm not actually using Platform.io as such for this demo. And you can replicate this on your Arduino or within Visual Studio Code yourself quite happily, but I'm not going to go anywhere near that. It just takes far too long. So let's have a look at this swap function. All it's going to do is literally take two digits, in this case AA, double B, and go swap them over. Yeah, that sort of function is used all the time in sorts and things. So A becomes B, B becomes A. Simple, right? So, well, what is there to it? Yeah, we're going to have a temporary variable that takes the value of AA. Double A then becomes equal to double B, and double B becomes equal to the temporary variable. Ta-da! It's done. Takes all of a nanosecond, and that's it. And in here, I've got this long line here that just outputs something to the console, so we can see what's going on and prove that it's working. That A is now equal to B, or what B was anyway, and B is now equal to what A was. And if you're thinking, what on earth is all this std : that's C++, and is what you and me would be using if it were not for the Arduino framework that sort of hides all that from us. You'd probably use something like what's on the next line, some sort of serial print or print line. The trouble is, to do that line above it with serial.print lines would take about 4 lines, because you can't sort of put variables inside it, can you? So you'd end up doing with a serial print inside swap function AA equals, and then you'd have another one saying serial print AA, and then another line saying serial print BB equals, in quotes, and then the final line, serial print line, saying this is the value of double B. It's all a bit convoluted, and frankly I don't like it at all, which is why I did an entire video on how we can get printf working inside an Arduino environment. And yes, it takes a little bit of memory, but I mean, unless your sketches are huge, it's certainly worth the trouble of doing it, because then you can write something like this, which is concise and easy to understand. You're saying inside swap function AA equals %D, which stands for a decimal value, double B equals %D, another decimal value, and then you give the decimal values that you expect to appear in order. And whilst printf is not C++, it is actually C. And cout, the one I'm using, is C++. Printf works great, and I highly recommend it. Hence that video. Anyway, moving on, let's focus now on what we're using, variables and references and so on. Just bringing things to a screeching halt for a second. If you know all about functions, you know what parameters are to a function and why we need them and what they can and can't do, then use the chapter indications along the footer of this screen and skip to the bit where we talk about references and pointers. Don't hang around here getting bored being taught stuff you already know. Just saying, okay? So we've written this function here then. It just takes two integers. Now when you declare a function like this, what you're actually telling the compiler is, I'm actually wanting an int AA in the same way as we're saying int temp here, except we've declared these up here as parameters to say declare these integers, but these are actually incoming ones, so allow these to be passed to me. So if you know anything about what's going on behind the scenes, the compiler says, great, I'll have a memory location for AA and a memory location for B, and that's it. That's where they're going to sit in your SRAM. Yeah, when this function gets invoked. Now when this function as a whole finishes down here, so all this is run and it gets to the bottom here, it's printed something out. At this point here, these two variables disappear into the ether. They are no longer valid, yeah, because the lifetime or the scope of those variables only exists for the lifetime of the function call, right? And you know all that, I'm sure. So let's have a look at the main function that calls this then to swap those two variables around. Okay, here we have an int main. Main is the standard C or C++ entry point to any program, a bit like your loop, except this doesn't loop around unless you make it do so. It just runs once and then stops. And behind the scenes in Arduino world, there is a main, except that you don't get to see it, not usually anyway. And the main says go and run the setup and then go and run the loop forever. There's no magic to it. That's what's happening, but you never get to see that because the Arduino guys, clever guys that they were, hid all that from us and let us get on with the main job of setup and loop. But here we have an actual main, and yes, it's supposed to return an integer when it stops. Anyway, this function then has two integers, A and B, and we're outputting a line just like we did before to saying, right, before we call anything, let's just prove that A and B really equal what we think they do up here. Then we're going to call the swap function that we just had a look at and pass them those two variables, A and B. So what we're expecting at this point is A to become B and B to become A. So we're saying A, I want to be equal to 10 and B equal to 5. Just swap them over, right? Good. And after the swap, we're going to print out another line just to prove that it's done that. And then the function ends and we've always got to return something, otherwise the compiler gets a bit narky with us. And that's it really. So let's just run this in its entirety and just see what the output looks like. Right, there we are. So it's just whizzed through. So it's saying before the swap, A is equal to 5 as it expects, because that's what we set it to up here. B is equal to 10. Great, that's the bit there. Yes, that's that top line there, outputting that variable, that message. Now inside the swap function, it's going to yes, my incoming variables, the two up here, AA is equal to 10 and BB is equal to 5. I mean, there's nothing magical about this. There's no smoke and mirrors. It's as you'd expect it to happen. And then after the swap, when it's come back from the swap, it says A is equal to oh, hang on a minute. A is equal to 5 again and B is equal to 10. Hang on, I thought we swapped these over. All right, I know lots of you are streets ahead of what I'm trying to say here, and I guess I'm not really aiming this video at you, am I? I'm aiming this video at the people who don't quite understand what's gone on here. How come it seems to have worked, the swap bit inside the swap function, but when it comes back from the swap function, it's back to what it was before? How can this be? Well, the very simple explanation is that when you pass parameters into a function like this, or perhaps more specifically when you pass them in where they've been declared like this, what you're actually doing is just saying these integers that I'm declaring up here as the function, as I said, they're two independent memory locations. They are not the same memory locations as these two here that we're passing in. So you've got A as a memory location, B as a memory location, then you've got AA and B. Yeah, and they're four independent memory locations. So yeah, the swap gets passed values copied into its own variables. So it gets a 5 and it gets a 10. It does its thing with it, and that's it. Those values it's mucked about with don't go anywhere. They just disappear into the ether, and then this function carries on. And it goes, well, I've still got my A and B. Look, why would they be touched? They're independent from anything else. So, now it could be useful then, couldn't it, for those variables to actually be updated and be seen to be updated from the calling program. Okay, all that has come to the point where we now say, yes, now we need to understand how we can pass those variables into the swap routine, the function here, and have it actually update the original values here without creating copies in memory and all the other things. Yeah, okay, simple little change, and well, almost the end of the video really. So what I'm saying is then, if we want to pass in the variables here so that what it's updating is not an independent copy of that variable, but the actual variable that's been passed into it, so it can change it and the calling routine can see that change, we simply add in an ampersand on there and on the other one. And well, before I explain what's going on, just that one change, let's run this again and see what kind of output we get down here. And here we have it. So we started off with A equals 5, B equals 10. Within the swap function it was 10 and 5. When it comes back, tra-la, it's 10 and 5 again. It's magic. Well, no, it's not magic actually, it's references. Because what we've done here, instead of declaring a simple integer, int AA, we're saying integer reference that I'm going to call AA as an alias, but it's actually the real value that we're passing in. What was that, Ralph? What are you talking about? What? Let's put this a different way. Right, we've got to clean the screen now. So what we're saying is we're declaring two integers here and we're passing them into this swap routine. Now, as a consumer of that swap function, you don't really know whether you're passing them in by value or whether you're passing them in by reference, because the swap function could be buried deep in a library somewhere that you have no interest in really other than to consume it, and you might not know that it's actually going to change the value, because the only change we did was add in this ampersand and turn this integer AA into integer reference AA. So it says I'm referring to the variable that's being passed in to me as AA, that I'm calling AA, because after all, the person who wrote the swap routine doesn't know what you're going to call it, so it just makes up a name. We could call it Fred. We could even have called it A, the same name as what you're passing in, because it's just a name that only exists for the lifetime of this little function here, yeah, and disappears again after that. So we're saying this is an integer reference now that I'm calling AA, and this is an integer reference of B. And by reference, I mean we're referring to whatever it is that was passed in. So we're referring to tra-la, this variable here, A, and B here. So we're referring to those ones. And therefore, yes, we can indeed update those values, and that because it's the same memory location. We haven't created copies of them. It's the same memory location, and the value will obviously be seen by the calling program. And that is how you pass references in to a function, by changing the function itself and say you put this ampersand in, which is a reference. Great. That's it. Well, we could actually stop the video now, because to be quite honest, within C++, that's about as much as you need to know. Yeah, especially at the level at which we're aiming this video, sort of the beginner to intermediate coder. Yes, because if you are screaming at the screens and you've forgotten this and you haven't told me that, well, you already know that. I'm aiming this at the beginner who has no idea what a reference is, but hopefully now they do. And that's as much as you need, because within C++ you have this reference. Within C, the old boys who used to write C, yeah, they can't do this. No, you have to use a pointer. Oh no, don't tell me about pointers. Well, I could tell you about pointers. It's complicated, and I guess the only thing I want to tell you about pointers is so that if you see it in a program, and there are plenty of libraries out there that use pointers because they're written by people who ostensibly are writing in C++, but they're not. They're writing in C most of the time because that's probably where they've come from. Well, a bit like what I was saying earlier on, wasn't it? Where printf, I mean, everybody uses printf, but it's C, not C++, so we should be using something else. Yeah, like cout, for example. Well, it doesn't matter, except that pointers are, well, I suppose we could use the word dangerous, but, well, yes, let's use the word dangerous. Because the trouble with pointers is that they are exactly as their name implies. They point to a particular memory location. And you point to the wrong memory location because your coding is not optimal. You're just pointing somewhere, possibly in the middle of the stack, the heap, the bit of program memory. I mean, it could be pointing anywhere. The onus is on you to get it right. That's the problem with pointers. Behind the scenes, don't tell anyone this, but behind the scenes, references like I've just written up there with that ampersand have got pointers all working for them behind the scenes. But C++ sort of abstracts that away, doesn't it? It says, look, you don't have to worry about all that. We'll deal with that. You just tell me it's a reference and I'll do the necessary. That makes it very, very easy, isn't it, for us programmers just to put an ampersand as part of the declaration of a function to say, yeah, I actually want to update this variable, so I'll make it a reference to that variable. Simple. Okay, if we were going to use pointers for this one then, and to be quite honest, if you think I don't want to know, if this is good enough for you, you can just skip the next bit of the video, press the old right button on YouTube and it will zoop it along. But I'll tell you about pointers just so that you can recognise what we'd have to do to this to make it work with pointers. We'll pretend C++ doesn't really exist. As you can see, the code on the screen is currently set up to allow references. So these ampersands up here turn these declarations here from an integer to an integer reference. Fine. Okay, let's undo that and see what we've got to do now to make this use pointers, which, as we said, are, well, as the name implies, they're just memory locations somewhere in my 32 gig of RAM. It goes that one there and that one there. And pointers are always, well, in our world anyway, 2 bytes. They are, in fact, integers themselves. That's sort of irrelevant, really. So when you see a declaration for a pointer, don't start thinking we're describing the pointer. A pointer is a pointer is a pointer. You don't have to describe that. You're saying the thing I'm declaring now is of this type. So look, up here, we can say, not a reference, we can say an integer pointer. Yes, the asterisk. Hurrah! So an integer pointer, which does not mean the pointer is an integer, because it is, but that's beside the point. We're declaring a variable AA as an integer pointer. In other words, it's pointing to a variable that is an integer. And I guess that way it knows that it's 2 bytes long as well, yeah? So, is it that easy? Can we just put a little asterisk in there and go, hooray, we've done it like we did references? No, of course not. As you can see already, we're getting squiggles here under the A, squiggles here, squiggles down here in the calling, because it's the wrong type. Yeah, we've said now this function has been defined to say I want a pointer to a variable, not an actual variable itself, and yet you've coded it as though it were a variable, so that's all nonsense. Go away and fix it. Okay, let's fix it then. Now, one of the main problems with pointers is that they use 2 symbols, the asterisk, as you've just seen, and the ampersand, and they mean different things depending on where they are in the code. So you see an asterisk, you go, oh, that's an integer pointer declaration. No, it isn't always. The one I've just done up there most certainly is. We're saying this is an integer pointer called AA. This is an integer pointer called BB. Yeah, what's that? You've seen it written differently to that. What do you mean? Oh, the spacing. All right, let's address that as well as we're talking about pointers. You might find this written as integer space asterisk BB, or integer space asterisk BB, like that. Yeah, 3 ways of writing it, none of which are wrong. But in my view, what you're saying, and which is why I write it the way I do, is that this is not an integer of a pointer BB. This is an integer pointer to a variable called bb, yeah, which is a little bit different. Hello, what have I touched? There we are. Right, so that's why I put the asterisk next to the type that I'm declaring. So an integer pointer or a character pointer or whatever it is. Yeah, it's not wrong doing it the other way, but it just makes it, in my view, clearer this way. Yeah, I know. There's probably 50 people that's screaming at the screen right now saying, you've done that wrong. Anyway, let's move on. Now, to get all this swapping around, obviously we've got to get the value that the pointer's pointing to. Yeah, we've got the value of the pointer itself, the memory address now. Well, we will have when we've fixed it all. So when we say int temp equals AA, well, we can't do that, can we? Because AA is a pointer. That's right. It's not a value anymore. To get the value of the thing the pointer's pointing to, you've got to put an asterisk in front of it, like that. Now what that is dereferencing the pointer. Yeah, it's another term for you to throw at your nearest party or get together. Oh yes, I've been doing lots of dereferencing today, you know. But that asterisk, this is the important thing, that asterisk is not the same as that asterisk up there, which is, well, I'm a little bit disappointed really in C itself, why they happen to use the same symbol. Yes, they're related, obviously, because they're all talking about pointers, but why not use something like a caret sign, you know, the hat above the 6, is it? Yeah. You know, just to make it absolutely clear to people what it is you're talking about. I guess it's the way it is, and we have to live with it. So what we're saying here then is int temp is equal to the value, the underlying value of whatever's pointed to by the pointer AA. Great, okay, that's worked. The next line though is a bit problematic. It hasn't complained about it, but that's never going to work. What we're saying here is the pointer AA, because we know AA is an integer pointer because we've declared it up here, is now equal to the pointer BB. Well, that's nonsense, isn't it? If A was pointing to a variable at address hex DEF123, we're now saying AA is now pointing to the B address of XYZ496 over there. Yeah, that wasn't hex. Yeah, I know, I forgot. It's nonsense. So to do this, what we're trying to say is the value pointed to by AA is equal to the value pointing by BB. Okay, that's fine. And then we're going to say the value of BB is equal to temp. Now temp is just a standard integer. It's not a pointer or anything. It's just a standard value, yeah, because we've declared it here. And that's what we're saying. The value of the pointing thing here, BB, is equal to temp. There we are. So what we've got here then is a mixture of asterisks up here and then asterisks down here, which are not the same as the asterisks up here. They mean something else. Here they're all dereferencing things, and here they're declaring the type that you're pointing to. You're saying this is an integer pointer. Yeah. Here you're saying I want the value of, dereference this pointer and give me the value. Yeah, I know. I knew I shouldn't have started this video. It's just... Anyway, that's not the only problem we got, is it? Down here, look, swap AB. It's saying squiggle, squiggle. And that's because we're passing in to this routine at the moment, we're passing in an actual value of A and B. It goes, hang on, that's not what I'm expecting. I'm expecting a pointer, aren't I? And you've not given me a pointer, so that's syntactically incorrect. How do we pass in a pointer to a value or a variable here? Well, you've seen it once, but it's sort of different in a way. To do this, we say swap the variable located at a particular address, and we use the ampersand. And ditto, we'll have to do that for B as well. So what this is now saying, yeah, I know. We're saying swap the value pointed at by this address and by this address, at A and B. And when this gets called over here, swap is saying, oh good, you've given me a pointer of one variable and you give me a pointer of another variable. That's fine. I don't know what the values are yet because you've not asked me to look at them. And then we get into the code and we say temp is equal to the value of the pointer pointed to by AA, because we put a dereferencing asterisk at the beginning. And then we get the value of AA and the value of BB and assign it to AA. So whatever AA is pointing to now contains the value of BB. And BB then becomes the value of whatever temp was. It's exactly the same logic as what we just had, but there's lots of asterisks and ampersands and all sorts of things going on here. Let's just run this and see if we get the same results as we did down here. Fingers crossed, eh? Let's have a look. Might not even compile. Let's have a look. Oh, look at this. It can't find the specified path. This is a problem with Visual Studio, actually, rather than anything else. There we are. Right. Oh, that's interesting. Oh, yes, of course. We forgot one, didn't we? Right, let's walk through these results, shall we? We're saying, right, before we did the swap, A is 5 and B is 10, just as it always was. Inside the swap, we're saying A is equal to this big long hexadecimal number and B is equal to this one. Why is that, do you think? Because the output here is saying AA is equal to AA. And what is AA? Well, it's an integer pointer. And ditto BB is an integer pointer. So what we've actually printed off here is the actual pointer value, which isn't really useful to us to look at, is it? But it does prove that it is a pointer value. So we've passed in the pointer value, fine. But behind the scenes, we've grabbed whatever they're pointing at, because when it comes back out, it goes, look, A is now 10 and B is 5. So it has swapped them over. Yeah, that's what we wanted. But oh my, just look at that code, all the asterisks and ampersands and everything else, just to make a simple little switch of a variable compared to using references. Yeah. Let's think for a minute the advantages of using this method against using the reference of a single ampersand. Let's just have a little think about that, because I'm sure if I think long and hard enough, I'll come up with no. At our level, definitely not. Okay, I know that experienced programmers will say, well, I want to do a bit of memory management myself and create variables using a pointer and grab the memory and keep it by using the new keyword. But even that has now been superseded in C++. Say, well, look, if you really want to do that, within your function like swap, if you wanted to create a pointer to a bit of memory that you're just working on, and you want it to exist after the function has ended down here, don't use a pointer, use a smart pointer, because a smart pointer will manage that memory and get rid of it into the ether when nobody's using it anymore. But I'm not going to cover smart pointers. We don't need those. Highly unlikely. Highly unlikely. I think I've used them once or twice in my entire work on Arduino and ESP32 stuff. We just don't need it. But if you want to recreate this little routine on your Arduino or ESP32, be my guest. Don't get confused about the asterisks here, because they're not the same as the asterisks up here. And don't get confused about the address of ampersands here. They're not references, they're address of. So swap the address of A and the address of B. Yeah, similar to, but not the same as references. I know which one I prefer. Now, it's just worth mentioning at this point that passing by reference instead of by value, which is the default, does have some benefits in some situations. If you're just passing a simple integer value across, it's only 2 bytes. And whether you pass it as a pointer, a reference, or as the value itself makes no difference at all to the speed of your program, right? Even if you're passing, 20 integers across, it's just trivial. However, if you're passing a huge big string across, let's say 1,000 bytes, then that most definitely does matter, because if you're passing it by value, then it's got to copy those 1,000 bytes into another bit of memory and pass that across. Yeah. Now, the 1,000 bytes, of course, has somehow got to fit in your memory for a start, and then there's a time taken to copy all the 1,000 bytes across. However, how often do we pass 1,000 bytes across to a function? Not very often. And if you're thinking, hang on a minute, I've got a couple of arrays that I move about and do stuff. Well, the bad and good news, I suppose, is that in C++, arrays, true arrays, are passed by pointer value anyway, not by value. In fact, the first element address is passed to the function, and that's all it knows. It doesn't know how long the array is anyway, which is another good reason not to use arrays in C++. Use vectors. Vectors can be passed by value or reference exactly the same way as we've shown in this demo here. So really, I guess the point I'm making here is, don't worry about the cost of doing all this. If you're using C++ properly, and you should be, then it's a no-brainer, and you just pass it either by value or by reference and ignore pointers. I'll say it again, ignore pointers. Don't use them, please. Okay, that's it. I think we're done here as far as references and pointers are concerned. You've had a look at the pointers. You've seen how complex it can be. Not for the faint-hearted, and in fact not for us C++ programmers either. Use references that are simple to do and are normally in the called function that you declare the reference. And your calling program doesn't really know whether you've got a reference or a pass by value parameter. Yeah, it doesn't really matter, does it? The point is, it's easy to do and abstracts all that complexity away. Now, if you think, no, Ralph, you're wrong, pointers have got a very valuable place in C++, and I'll tell you for why. Good. Tell me for why in the comments. And if you start talking about creating new variables, like a new integer or something, I shall delete your comment or put something rude on it. Yes, I will indeed, because we are not in that ballpark for beginners learning about references and pointers. Okay, I think we're done. Don't forget, if you like this sort of stuff, yeah, do give me a thumbs up.
Hey!
Yeah, and if you want to subscribe, if great, that'd be lovely to have you subscribed to my channel. And don't forget, what else you got to do? That's right, you got to tick that bell, because otherwise you won't be notified of any future videos. That would be sad, wouldn't it? So, in the meantime, see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.